faster than the fabric of space-time can keep up with it. And it'll just rip. And I'm terrified by this.
As we speak, the night sky is gearing up for a transformation so drastic it could look unrecognizable in just a few decades, or maybe even sooner. Astronomers across the globe are sounding the alarm, and now big names like Neil deGrasse Tyson are confirming the unthinkable. Polaris, our iconic North Star, might be on the brink of a cataclysmic explosion. The story behind this looming event is nothing short of chilling. For centuries, Polaris has been our cosmic compass, the one star navigators, explorers, and astronomers could rely on without fail. Its unwavering position made it the ultimate point of reference in the northern sky. But that stability? It could vanish in the blink of an eye, shaking up everything from stargazing traditions to astronomical measurements we've trusted for generations. The turning point came when a shocking research paper, presented by the prestigious Royal Astronomical Society in September 2023, revealed a grim possibility. Polaris is edging dangerously close to its violent end, ready to explode and disappear forever. The ripple effect on navigation, space research, and even our cultural connection to the night sky could be massive. Before we break down the consequences, let's get to know this cosmic legend. Polaris, also called the North Star or Pole Star, earns its fame thanks to its prime location, almost perfectly aligned with Earth's celestial North Pole. That's why it appears locked in place in the night sky, while the rest of the stars seem to spin around it. It calls the constellation Ursa Minor home, better known as the Little Dipper or the Small Bear. Despite its modest brightness to the naked eye, Polaris is a true giant, a yellow-white supergiant star with a radius about 40 times larger than our Sun. But here's a twist. While most people think it's a lone star, it's actually part of an intricate triple star system, bound together in a celestial dance that's lasted for ages, but maybe not for much longer. The heart of this stellar drama lies in Polaris's hidden family, a celestial trio that's been quietly shaping the fate of our night sky. The main players are Polaris A and Polaris AB, locked together so tightly they appear as one brilliant point to the naked eye. But orbiting this powerful duo is a third companion, Polaris B, circling the pair in a cosmic dance that's lasted for centuries. These three stars constantly pull at each other with immense gravitational force, twisting their orbits and subtly changing how they shine. This gravitational tug-of-war doesn't just affect where they move, it can shift their brightness, alter their pulsations, and change their very nature. The truth is, astronomers still don't fully understand all the intricate ways these interactions unfold, but they know enough to suspect that one wrong cosmic nudge could send the whole system into chaos. Here's where it gets mind-blowing. Polaris sits a staggering 323 light-years away from us. That means the light hitting your eyes tonight actually left the star in the early 1700s. If Polaris exploded this very second, humanity wouldn't even see it happen until the year 2348. For all we know, the grand finale could have already played out centuries ago, and we're just waiting for the universe to deliver the news. For thousands of years, civilizations have placed immense trust in this one point of light. From guiding lost sailors through raging storms to leading ancient caravans across unforgiving deserts, Polaris has been more than just a star. It's been a lifeline. Its unwavering position near the celestial North Pole has made it an unshakable reference for navigation in the Northern Hemisphere, and across countless cultures, it's been celebrated as a symbol of stability, guidance, and destiny itself. For countless cultures, Polaris has stood as the ultimate symbol of constancy, a lone, steady flame in the swirling chaos of the night sky. Myths and folklore have long painted it as a celestial anchor, a beacon of stability and guidance that never strays from its post. To astronomers, its fixed spot wasn't just poetic, it was practical. It became the ultimate point of reference for charting other celestial bodies and tracking the grand motions of the heavens. But Polaris isn't just a static light, it's a Cepheid variable star, meaning it naturally pulses in brightness in a steady, predictable rhythm. Those gentle cycles once served as a cosmic ruler, helping scientists measure vast distances across space and fine-tune astronomical instruments with unmatched precision. For decades, its heartbeat-like pattern never faltered, until now. In a twist that has scientists uneasy, Polaris has broken its long-standing rhythm. Instead of its predictable cycle of dimming and brightening, the star has started flashing in a chaotic, erratic way that no one saw coming. Its pulsations are now irregular, sending astronomers scrambling to figure out what's going on. And here's the kicker. This strange behavior mirrors what's been observed in other stars on the brink of their explosive demise. The once steady elongation of Polaris' pulsation period is now stretching in unexpected ways, likely influenced by the complex gravitational tugging within its triple star system. To put it bluntly, the very heartbeat of the North Star is faltering, and if history is any guide, that's a bad sign for its future. Right now, Polaris's heartbeat is changing at a rate of 4.5 extra seconds per year, and while that might sound tiny, in the world of stars, it's massive. Some scientists take the cautious route, suggesting that these shifts could simply be the result of the gravitational wrestling match between Polaris's three stars, subtly tweaking its atmosphere and throwing off its pulsation cycle. But not everyone's buying that calm explanation. A growing number of astronomers believe Polaris could be heading for a spectacular and violent end, and they have reason to think so. Its strange, unpredictable flickering is eerily similar to another famous giant, Betelgeuse, the blazing red supergiant in Orion. Betelgeuse has also baffled scientists in recent years, dimming and brightening in ways that sparked global headlines about its possible imminent explosion. When you line up the data, the similarities between Polaris and Betelgeuse are chilling. Both massive stars, both long-time cosmic icons, both suddenly acting like they're on borrowed time. Experts know that many aging supergiants go through this phase before their final collapse, their once stable light turning erratic as they burn through the last of their fuel. NASA has kept a close eye on Betelgeuse, even issuing heightened alerts about its unusual behavior. Yet strangely, Polaris hasn't triggered the same level of public concern, at least not officially. Behind the scenes, though, some scientists are already whispering that Polaris could be on the same ticking clock. After all, every star's life is a grand but finite journey, and for some, the finale comes much sooner than we expect. Every star's life follows a grand arc, and Polaris is no exception. After forming, stars settle into the main sequence phase, where nuclear fusion keeps them steady for billions of years. But stability doesn't last forever. Once their hydrogen fuel runs dry, they swell into blazing red giants, their heat and brightness spiking dramatically before the inevitable, a supernova. In that final act, they hurl their outer layers into space in a spectacular light show, leaving behind only a dense, shrunken remnant, a white dwarf. Now here's where Polaris gets interesting. Its increasingly erratic pulsations suggest it may have entered the helium depletion stage, something seen in other massive Cepheid stars nearing their final curtain call. As these giants burn through the last of their helium, their pulses grow chaotic, their brightness shifting unpredictably, clear signs the clock is ticking. For Polaris, this could mean the fuse has already been lit. Still, scientists admit they don't have undeniable proof that the North Star is on the verge of its explosive finale. But the patterns are lining up all too well with stars in their twilight phases, and the astronomical community is watching with sharpened focus. If Polaris does go supernova, the spectacle will be unforgettable. It could blaze brighter than the moon, dominating the night sky for days, weeks, or even months. Our familiar constellations would suddenly look strange, Ursa Minor and the Big Dipper forever altered by the loss of their anchor point. The North Star as we know it would vanish, replaced by a burst of blinding light. possibly glowing in brilliant colors before slowly fading into history. For anyone alive to witness it, the sight would be one of the rarest and most awe-inspiring events in human memory. For us here on Earth, there's no need to panic. Polaris is far enough away that even if it blew itself apart tomorrow, we'd be perfectly safe. Sure, it wouldn't unleash the same jaw-dropping fireworks as Betelgeuse, but make no mistake, it would still be a sight worth remembering. The explosion could shine bright enough to be spotted without a telescope, its light lingering for weeks or even months, brushing against nearby stars and catching the eyes of stargazers around the world. Astronomers would be on high alert, their instruments locked in, ready to capture every flicker of the event. But the real question is, what happens to Polaris after the blast? Here's the twist. Despite being a giant star, Polaris might not go out in the classic supernova blaze we expect from its kind. Normally, a supernova is the ultimate finale for a massive star, triggered when it runs out of nuclear fuel. With nothing left to counteract its own gravity, the core collapses in on itself, creating a colossal shockwave that tears the star apart in one violent instant. From there, the remains could take one of several fates, becoming a dense neutron star or, in the case of the heaviest stars, collapsing even further into a black hole. The threshold for such a fate is huge. Usually a star needs to be at least 8 times the mass of our Sun. Polaris might not quite meet that mark, meaning its grand finale could be far more complex and less predictable than most supernova stories we know. When it comes to supernova, there are 2 main types, and they couldn't be more different. Type 2 supernova are the heavyweights, erupting from massive stars layered like cosmic onions. When their cores finally collapse, their outer shells blast outward in a furious explosion of light and energy that can be seen across galaxies. It's dramatic, violent, and, among dying giants, the most common way to go out. Type 1 supernovae, though, are sneakier. They happen in binary systems, often with a white dwarf quietly orbiting a larger companion star. In one scenario, that companion swells and starts spilling material onto the white dwarf like an overfilled cup. Once the white dwarf tips past a critical limit, about 1.4 times the mass of our Sun, it ignites in a runaway fusion reaction, detonating in a flash bright enough to rival an entire galaxy. In another scenario, 2 white dwarfs spiral closer and closer together until they collide and merge, triggering the same fate. Type Y supernovae are prized by astronomers because their brightness is so consistent that they serve as standard candles, letting us measure cosmic distances, calculate the universe's age, and even track its expansion rate. After the blast, whether it's type 1 or 2, the star's core faces one of 2 fates. It becomes a neutron star or a black hole. A neutron star is a mind-bending object, packing up to 3 times the Sun's mass into a sphere barely 20 kilometers wide, so dense that a teaspoon of its matter would outweigh a mountain. But if the collapsing core is even heavier, it takes the ultimate plunge, forming a black hole whose gravity is so intense that not even light can escape, leaving behind a void in the fabric of the cosmos itself. Polaris won't end in a fiery supernova. It's simply not massive enough. At about 5 times the Sun's mass, this Cepheid variable will instead shed its outer layers and quietly collapse into a white dwarf, a tiny, Earth-sized remnant packed with the mass of a star. Once that happens, the North Star we know will vanish from our sky forever. Scientists still compare Polaris's strange pulsations with famous stellar deaths like the Crab Nebula and SN 1987A, studying light curves, spectra, and elemental traces. By matching these patterns to Polaris's behavior, they hope to predict whether its final act will leave behind a faint nebula or something entirely unexpected. Comparing Polaris's irregular pulsations to dying stars could reveal whether it's heading for a burst or simply behaving in a way we've never seen before. But despite years of data, astronomers remain baffled. Its strange rhythm refuses to fit the usual patterns. Predicting the exact moment a star dies is nearly impossible, and Polaris's role as a key navigational anchor only adds to the stakes. Whether it quietly fades or surprises us with a rare finale, one thing is clear: its future is a cosmic mystery that demands urgent study. Polaris's strange behavior leaves astronomers with more questions than answers. If it were to vanish, we'd lose one of our most important navigational anchors, forcing a massive recalibration of telescopes and star charts worldwide. Its fate remains uncertain, but its importance is undeniable. Only time will reveal whether Polaris will fade quietly or shock the universe with an unforgettable finale. Until then, stay tuned, and don't forget to subscribe, like, share, and drop your thoughts in the comments.